1999. Answer the following questions using principles of chemical bonding and molecular structure. So A says, consider the carbon dioxide molecule, CO2, and the carbonate ion, CO3 with a -2. I, draw the complete Lewis electron dot structure for each. Go ahead and do that.
I think Mr. Craig just glitched.
I didn't glitch.
It was your connection from a different country.
Thank you.
That was funny.
Oh, no, I'm just stupid.
That's right. Julia saw me.
Yeah.
Okay. Oh.
No.
All right. Questions on I. Good. So each one of those would be worth 1 point. Double I, account for the fact that the carbon-oxygen bond length in carbonate is greater than that of the carbon-oxygen bond length in carbon dioxide. You drew a picture? Oh. So why is this statement true? Account for the fact. What is the main difference? And again, it says that it is greater or longer. Why? Has a what?
Negative charge.
A negative charge. So that's the reason why these bonds are longer.
Is it because it has one double bond and the other one has two?
Oh, this is what
And the
he
double
talked
bonds
about
are
the
shorter
one day
than the
with
single
like
bond.
one
Yeah.
and then the two and then the.
Kaylee?
So since CO3 has less electrons connecting oxygen and carbon than less chloride.
Ooh, I thought you were on to something.
The bonds between the oxygen and the carbon are single bonds in carbonate.
Ooh, I thought Andrew had it.
Is it just because there's more molecules? Wait, no, never mind.
Kaylee, second chance. Oof.
Greater than the length.
You want the like numbers in, like
So,
Because that has four. And
how many resonance structures does carbonate have?
I wrote down.
Was that a guess or do you know?
I'm for sure 3.
3 resonance structures. In other words, the double bond that's here can either be here or here. And actually, it keeps rotating around. So it keeps switching. So if we were to look at the length of these, it would be the average of 1 double bond and 2 single bonds. Where if you want to give it some math, 2 + 1 + 1 divided by 3 equals 3. Divided by 3 equals like 1 1/3. Whereas the carbon dioxide has what kind of bonding? Double, which double bonds are longer or shorter? Shorter than single bonds. So, and they're fixed. They're not changing. So you can talk about that the carbonate has 3 resonance structures where that double bond is switching oxygens, and it does it quite a bit. So the average of all the bonds in carbonate are longer because of that resonance structure. And if you want to give it some numbers, like what I did there, that if you want to count the 2, the 1, it doesn't mean anything. But at least what it's saying is that you have, on average, 1 1/3 bonds between an oxygen and a carbon.
So,
whereas the average is 2, a double bond.
so does carbon dioxide have any resonance structure?
No, because it is
Because they
fixed.
just can't. Okay.
Also, how would you know if a resonance structure is possible? That is a good question. Oh,
Polyps are not atoms. Right?
Kaylee. How would you recognize that it has that potential?
One double bond, like in this case, there are two single bonds and one double bond.
Okay.
So it can rotate back and forth. Right, time to use the word polarization.
Kind of, sort of, yeah.
Yeah.
But there's another way that you can tell that it's a polyatomic ion. And again, according to the formal charges, are all the formal charges for the oxygens 0? The answer is no.
Oh, so
Because 2 of the oxygens have single bonds, where all the oxygens would rather have what?
so if there's a charge, they would all rather have 2.
They'd rather have 2 shared and 2 lone. So in that situation where you have a polyatomic ion, which is the majority of the time where you have a charge, I can't think of another time where we have a charge and we don't have a poly, but those double bonds are switching places quite a bit. Also, let me throw out another shape here and ask you if this could have resonance. Is it possible for this to have resonance? Kaylee's shaking her head no. Why?
Hydrogen carbon
And carbon will never have a lone pair. Okay, so again, the key was in this one, how are the formal charges? Everybody's 0. Boom, nothing's changing. Okay. So if you want to talk about formal charges, resonance structures, you're spot on for that one. Okay. All right. That's always a fun one.
So if you just
Go ahead, Eric. Say what you were going to say.
average, if you just talk about the average, do you have enough?
It's not bad,
But you-
but if you're going to talk about the average, you have to talk that double bond keeps switching places. So if you can't remember the term resonance, say that double bond goes to the different oxygens.
And that's why it's average.
Yes.
So can you just say that the resonance structure has an average of like 1 and 1/3?
Bonds. Yeah, I like that.
And then the fixed has an average of 2, so therefore the whatever is greater.
That's money. And you piggybacked off of Eric, so nice job, Eric.
Yeah, good job.
Thank you, Mr. Craig.
Letter B. Consider the following molecules: CF4, SF4. Draw the complete Lewis dot electron. Draw the complete Lewis electron dot structure for each molecule. Oof. Rough. Should have like some music to accompany this. That was just recorded. Lovely. You want to wipe that off your shirt? Okay. How we doing?
Fantastic.
I couldn't hear you with Todd dropping something back there. Did you say silver or sulfur? Yes, sir. It's right below oxygen.
Silver hat.
silver has 2, but we don't care.
Okay. Yeah.
All right, double I. In terms of molecular geometry, account for the fact that CF4 molecule is nonpolar, where the SF4 is polar. Oh, really? Go do tell, Eric. That's what you're going to write? I guess we're not looking to earn points today.
So, hold on. Carbon tetrafluoride is non-polar because all the external atoms are the same and there are no lone pairs in the central atom.
And
Symmetrical.
there's one of 2 words that you must include.
And it's got geometry.
It's got dementia.
It's got
Good
geometry.
Lord.
Symmetrical geometry or whatever it is.
Oh my God, Jessica.
So that one is going to be polar, which is asymmetrical, and the other one is symmetrical.
Okay, so that's a good start.
Do you have this?
That one over there is polar, or that one. Okay, so I do want you to include symmetrical, asymmetrical. So let's talk about this one. The CF4 is symmetrical because,
All the external atoms are the same.
and
There are no lone pairs.
perfect. That's all you got to say.
Yes.
SF4 is polar
I said that.
because it is,
Asymmetrical.
because
it has a lone pair.
within
A trigonal bipyramidal.
or
Tetrahedral.
or
You saw?
seesaw. Yeah. So there's a lone pair of electrons in either the trigonal bipyramidal shape or it has a seesaw shape with the lone pair. 2002B. Using the principles of chemical bonding and molecular geometry, explain each of the following observations. Lewis electron dot diagrams and sketches of molecules may be helpful and will be helpful as part of your explanation. For each observation, your answer must include references to both substances. So you got to talk about both. All right. A, the bonds in nitrate ions are shorter than the bonds. Wait a minute. Nitrite ions are shorter than the bonds in nitrate ions.
Draw it out.
Draw them out.
This is going to be the resonance.
Why does that look like 3?
Wait, 3 times 4, 24. Thank you, Mackenzie.
What? Oh, you're looking at the other one.
Oh, wait.
Wait, what? So we've got 12
No,
plus
I'm
5
talking
minus
about
1, so 18. Yeah, I got the right number.
I don't
And then
know.
24 for this crypter.
Okay, I got it. Just good. I'm so
What is it? Oh, okay.
Oh boy. All right. So it says that the bonds in nitrate, that's this, are shorter than the bonds in, nitrite are shorter than the bonds in nitrate. Why?
Okay. Wait.
Averages. Let's take this to averages.
Okay. It says. I'm going to wait.
True or false? They both have resonance structures.
True. But NO3 has 3 resonance structures, while NO2 has 2.
Okay. So that's like not helpful, but go ahead. So what is the average for this?
3 over 2, 1.5.
1.5? Okay.
Or
And the average for these? 1 1/3?
oh, yeah.
Remember, the higher you get, so a single bond, double bond, triple bond means a higher number. So if you're doing this, the higher the number, the shorter the bond, because this is closer to a double bond than this. Okay. So this one is shorter. So if you want to talk about, they both have resonant structures, which means a double bond keeps moving places. However, the average of the bonds, and again, do we count lone pairs?
No.
No, because that's not a bond. That's a lone pair. That the average of the single and double is much shorter than the average of 2 single and 1 double. That's gold, baby. Okay. Questions on that?
That's really number. That's really telling. Think of it the higher
There you go. Dang. Wow. I couldn't have said that better. All right. Letter B. Uh-oh. The carbon hydrogen, or actually the CH2F2 molecule is polar. Boy, this is a no-brainer. Whereas the CF4 molecule is not. I don't know. I don't think there is an eraser box, sorry. Yep.
Well, I can kind of guess.
Oh, she's guessing now.
Educated guessing.
All right. Says that CH2F2 is polar. Do you agree with that?
Yes. Well, we have to agree with that because it tells us.
Okay. But you don't want to argue and say that this vector, these two vectors cancel out,
They have
and these
different
two
external
cancel
atoms.
out.
It's not.
Attaboy. There we go. Anytime you have different external atoms, I don't care what the shape is, it is always polar. So, what would your explanation be for CH2F2? And again, keep in mind, you must, where'd it go? Your answer must include both substances. So, CH2F2 is polar because, Jessica? The first part I missed. I thought you said something before that. Remember, you have to include it is symmetrical or asymmetrical, and then give what you just said. Okay, so is it symmetrical or asymmetrical? Atta girl. Asymmetrical because we have different external atoms. Nice. Whereas you're on a hot streak. Is because and money. Love it. Hopefully this is turning into a broken record. I like it. Questions on this? Back on it.
How much is this kind of stuff? We don't make these now?
Yep.
Like, is it chunk? Because this is not that bad.
Did you hear what he just said? This isn't that bad. Wait till he gets his test back.
The stuff that we did at the beginning, correct. The stuff that we did at the beginning, like the letters, like the N and like the L. We don't
The N and the L.
You know, like
Ah,
the spin.
so okay. May get to see some of that in the next couple days before Thursday. Yeah. All right, C. Yeah, C. The atoms in a C2H4 molecule are located on a single plane. Vroom plane. Whereas those of the C2H6 are not. Here, I'll give you a hint. Draw it out.
I drew it. The drawing doesn't tell me anything, Craig.
Oh, it's money. I love it.
Your lecture video may have told me, but this does not.
Here, I'll draw it this way instead. Money. Money. Okay?
No.
That's not how I drew it?
I mean, it's right, I guess.
Yeah.
Not just
You
how I-
guess?
But
Oh.
let's just not do it that way.
Do what way? What
It
were
makes-
you
It
doing?
makes me uncomfortable that they're.
Emma and I stacked ours like
Yeah.
a normal box.
Yeah, see, that's crazy talk. All right. So let's take a look, first of all, because you will be asked, or actually, I'll ask in addition, what geometry is around that carbon that I just drew a triangle around?
Triangle.
Oh, gosh.
The geometry. Molecular geometry. A trigonal what? Oh, planar. Okay. So what kind of geometry did I draw around that carbon? Oh, a planar. Planar. Okay.
Wait.
So we have two trigonal planars on the same plane.
How do you,
Huh.
But how did you know to draw it like? How would those of us who aren't AP teachers know how to draw it like that?
So I'm guessing that you drew it like
Like a
this.
box.
Like this,
You're just gonna.
Yeah.
which is like this.
Oh, wait, no.
Yeah.
Yeah.
No.
Okay. So what shape did I just
Oh.
create?
What?
Which is probably. Oh my
No, don't
God.
look. Don't look.
So we have two triangles on the same plane.
Oh.
Okay. All right. So what do we have?
Two triangles here too. Look, do, and then do.
Well, you would be wrong on that one because, careful, our central atom is the carbon. So what type of geometry do we have around the carbon that I have an arrow pointed toward? Tetrahedral,
This is so big. I'm
which is
definitely
a
going.
three-dimensional object. And what kind of shape do we have around the
Okay,
second carbon?
but how do you know to draw a rhombus?
What's a rhombus? Oh, a square on the side? Yeah. Okay. There's a square now.
Okay, but how do you know that it wasn't a triangle?
Ah.
Like, if you took, like, just this, like, the carbon, what are the atoms around it?
Hydrogen. Two hydrogen.
Very
And
nice.
the carbon.
Okay.
And the carbon.
Yeah, so all of these are included. So, like, these are this carbon's external atoms. So you
Oh.
So to piggyback off of what Emma just
Okay,
asked,
that makes sense. now.
not that it's
I
bad,
get it. It's rhombuses.
okay? Rhombuses.
Rhombus.
Rhombi.
It's rhombi.
What is the bond angle? Wasn't asked between the hydrogen and the carbon there.
120.
That's how we know it's trigonal planar.
Got you now.
What is
I
the bond
forgot
angle here?
109.
Oh, 109. Yeah, not 90. Good.
0.5 actually.
Okay. Let's continue this.
It's on the, like, neck.
Oh.
So
How many
Words.
sigmas, how many pies do we have in this shape right here?
5 sigmas, 1 pi.
The whole thing.
Yeah, 5 sigmas, 1 pi.
Okay. How many? Oh, that was really bad.
That's a small.
Why am I not able to? Hold on. There we go. That's,
It's okay. Not
dear
everyone's
bud.
artist.
so how many sigma? Pi?
0, and you have to write the 0. You
Good.
can't just leave it blank.
Very good.
There's one thing I remember. It's that.
Is everybody good?
I don't understand why we're doing
Explain it in
rhombuses
words.
and triangles.
How do you explain what in words?
That they're not on the same plane because it says. the
Are you
color.
saying over on this one?
Yeah.
Because you can say that, oh, don't erase it. You can say that the geometry around the right carbon, if you want to say that, or the left carbon, or each carbon, is a tetrahedral shape, which has what kind of hybridization? Ooh,
Oh, SP3.
sp3. So if you want to just say that it has sp3 hybridization, that too is nice.
That's it.
Whereas
Just say it's 3D.
both carbons here have sp2 hybridization.
Call from a random
So the
person.
geometry around
And you answered it. Brilliant.
adoption.
Hello?
You make them, we take them.
Wow. Why would you ever answer? Block the
No,
number.
it's
and move
regarding
on.
new health insurance.
Well, thank God for that. Because
Wait,
you're a
okay.
grandma and you need it.
So the geometry around the right carbon is what?
Wait. Which shape are we talking about?
This one, like, do I just
The one on.
The one with the SP3.
So this right here has sp3 hybridization. Is that what you're asking?
That's all I need to say.
Well, not all, but
Well,
it helps to seal the
okay.
deal of tetrahedral,
Oh, wow.
which is a three-dimensional shape that has 109 degree bonding angles.
Okay.
Say this C2H4 is trigonal planar, which means it's on a plane.
That each carbon has that geometry.
Yeah, so you
Yes.
say the C2H4, each carbon has a trigonal planar geometry.
Perfect.
Which means it's on the same plane, whereas the C2H6, each carbon has a tetrahedral shape, which means it's no longer on the same plane.
Love it.
So we don't talk about SP3 or SP2.
So the geometry.
You have to talk about sp3.
No, I don't. No.
I will make sure that
No.
if you don't say it, then it's no points for you.
Okay.
All right, let's see. Hubbity bubbity bubbity. Where are we at? D. The shape of PF5 differs from that of IF5. I don't know why it's a big 5 there, but okay. Doo-doo-doo.
5
Roll
plus 28. 33.
Actually, let's just do this.
Oh, it's 5 fluorines. That's 35 plus 5. 40.
Sweet.
What? Oh, I don't like how you're drawing stuff.
Ew, what?
Yeah, no.
But it's okay.
Gold.
It looks like a starfish. Like if you put triangles around it. Okay,
What?
Triangle.
On this, would you want us
I'm
to
gonna-
show us what would the board be like counting showing our addition of
I would always, if you don't know how to draw your Lewis dot structures, yeah.
Question, would this be wrong?
You saying I don't know?
No, that's gold. I like that.
He's
Alice, what a silly question.
I'm sorry.
Yeah, Alice, when have you ever
All
been
right,
wrong?
so the shape of PF5. What is this shape?
On the right side, Alice, not as wrong as me.
Trigonobipyramidal. And what is the shape of the IF5?
Square pyramidal.
Nice. Square pyramidal. Okay. So
Guys,
you can identify the shape. You can talk about the bond angles, which the bond angles for the trigonobipyramidal are what?
90, 20.
90 and 120.
That's right.
Whereas the square pyramidal has bond angles of
90.
90. The hybridization for the trigonobipyramidal
Oh, SP. DSP.
or sp3d, I don't care. Whereas,
SP2, SP3.
okay. Also, while we're on it, how many sigma bonds does this PF5 have?
5,
5. How many pi?
0.
Whereas the square pyramidal has, nice, and pi?
0.
0. Okay, so I probably wouldn't use the argument of sigma and pi bonds here
It's the same.
because they are the same, because we do not care about lone pairs. However, the shapes, the bond angles, and the hybridization are all good things. And guess what? You can bullet point, or do bullet points for that.
Oh, so we don't even have phrase sentences? Let's go.
We can just list that.
And of course, draw the structure.
Yeah, but we can just
Yeah.
list it. Oh,
Yep.
cool.
That's so exciting. Can you make the entire tests? Except I don't know the chart, so
Oof.
that might be hard for me.
Blah, blah, blah.
Trigonal planar.
We'll learn it on our way down to the
Yes.
Yeah. What's that? Oh,
Trigonal back from middle. Seesaw.
Okay,
Trigonal
linear.
planar.
how many have we done?
Actually, just trigonal planar.
Yeah, let's call it a day.
Yes.
Yes.
Let's go.